Okay, so this is the review for the pre-cal final, chapters 1 through 5. And we are going to do the first 5 problems or so in this video, and then I will do the remaining after that. Okay, so the first problem is a composition function problem. We're given 2 functions. We're given f, and we are also given the function g. And the question asks us to find what is f of g, as well as finding its domain. So let's find f of g first. F of g can also be written as f of g of x. So what that means is we want to go to the function f, and we want to replace the input, which is x, with the entire function g. So let's go to function f, which is 2 times x, but instead of x, that's going to be our input. So 2 times the input plus 3. And the input is the entire function g, which is the square root of 4x minus 1. So the square root of 4x minus 1 is going to go in place of x. There's not a whole lot we can do with this. We can rewrite it without the parentheses. So we could just say the square root of 2 times the square root of 4x minus 1 plus 3. Not a lot of algebra we can do to simplify that. But now the question says, what is the domain of this function? So whenever we're finding the domain of a composition, we have to consider 2 things. We have to consider the domain of the result, and we also have to consider the domain of the input function. Now in this situation, both of them are going to end up being the same, just because of the way it worked out. But let's look at the domain of the result. So we're looking at the domain of 2 times the square root of 4x minus 1 plus 3. To consider the domain of that thing, we want to look for any of the 3 red flags. And the red flag that we have here is we're taking the square root. And remember, we can't take the square root of a negative number. So what we want to do is we want to say that whatever is inside the square root, 4x minus 1, has to be positive or 0. Cannot be negative. So we can set up the inequality 4x minus 1 has to be greater than or equal to 0. Solve that inequality, and we've got the domain. So let's add 1 to both sides. So 4x is greater than or equal to 1. Divide both sides by 4, and x is greater than or equal to 1/4. Okay? Now if we look at the domain of the input function, which in our situation was g, the square root of 4x minus 1, that's going to end up being the same. So the domain for this function is x has to be greater than or equal to 1/4. Okay, so next problem, number 2, is talking about even and odd functions. There's a couple of ways to look at this, but first let's look at this algebraically. So 2x squared plus 3, that is going to be our function. So f of x is 2x squared plus 3. To figure out if this is even or odd, we need to calculate or figure out what is f of negative x, and also what is negative f of x. Okay, so we can figure out f of negative x by replacing x with negative x. Okay, but what happens is when we have a negative number and we square it, any negative number times itself, or any negative times a negative, is going to be positive. So this just simply becomes 2x squared plus 3. Now if you look at this, this actually matches the original function. And because these 2 things match, this is an even function. Okay, now if we had actually calculated negative f of x, which we'll do, if that matched f of negative x, so if these 2 guys match, then that would be an odd function. But since these 2 guys match, that's an even function. Okay, let's go ahead and calculate negative f of x. We can calculate negative f of x simply by negating the entire function. Okay, so if we distribute this negative, we get negative 2x squared minus 3. Notice that this does not match the other 2 guys, either f of x or f of negative x. therefore it is only an even function. And in fact, everything except a basic function is going to be either even or odd, but not both. Okay, so let's look at the other function in number 2, which is 3x divided by 4. So let's go ahead and figure out what is f of negative x, and then also what is negative f of x. Okay, so f of negative x we can find just by replacing x with negative x. And if we simplify that, that's just negative 3x over 4. Now, if we look at negative f of x, that's the same thing as just negating the entire function, which actually does match f of negative x. So since these two things are equivalent, we can say that this function is odd. Now, a little trick, if it's a polynomial function, is any even function will only have even exponents, and any odd function will only have odd exponents. So that's a good trick. Another trick, or not trick, but another way to determine whether it's even or odd is to look at the graph. So if we look at the graph of the first one, if I can get the calculator going here, y equals, it was 2x squared plus 3. If we look at the graph of that thing, notice that we have some symmetry here. This graph is symmetric with respect to the y-axis. So what that means is, if we were to draw a line down the y-axis here and flip it across that, we have the same thing on both sides. Okay, so anytime a function is symmetric with respect to the y-axis, that's an even function. Looking at the other function, if we were to graph that, y equals 3x divided by 4, that function is a line that goes through the origin, and that is symmetric with respect to the origin, which is a little bit easier to see in a line here. And any odd function is going to be symmetric with respect to the origin. So I would like for you to be able to do this both graphically as well as algebraically, as we did at the beginning. Okay, number 3 is a calculator question. Number 3 says, where is this function increasing, where is it decreasing, and then what are the local minimums and maximums. Okay, so f of x, 2x cubed minus 4x. So this is strictly a calculator question. In order to do this, we need to graph it in our calculator. Okay, so we're going to graph this thing in our calculator and then use the calculate functions to figure out where the minimum and maximum are. Okay, so 2x cubed minus 4x. Let's graph that. And you can see it does all sorts of stuff, goes up and down, up and down. So we want to know basically what are the high points and what are the low points, and then determine where it's increasing and decreasing from that. So these two guys, the peak is going to be the maximum, and the valley is going to be the minimum. So we want to know what are those values. So to do that, we can go back to our calculator, and we can do second calculate. And then if we want to find the maximum, we can go down to number 4, maximum, press enter. And notice it says left bound, so we want to go to the left of where we know the maximum is. And then it says right bound. We want to go to the right of where we know the maximum is. And then it's going to ask us to approximate where we think it is. Press enter. And here we go. We get that the maximum happens when x is negative 0.816. But the actual maximum, the actual height at that point is 2.177. Okay, so we can go ahead and say that the maximum is 2.177, and that occurs at negative 0.816. So this is the y value, this is the x value. Now we can repeat that same process for the minimum. So go back to our calculator here, and instead of maximum, we're going to choose minimum. Left bound, we want to make sure we are to the left of where we know the minimum is, just by looking at it. And then it's going to say right bound, go to the right, and guess is in the middle. Okay, so similar situation here, just flipped over because it's an odd function. And we see that the minimum happens when x is 0.816 and the actual minimum is negative 2.177. So we can go ahead and write that the min is negative 2.177, and that happens when x is 0.816. Okay, so now that we know the min and the maximum, now let's figure out where is this function increasing and where is this function decreasing. Okay, so we're going to create intervals here. So if we're looking at this, the graph of this function, we could circle the areas where we know it's increasing. We know it's increasing there. So if we were a little ant crawling up the hill, we would be going up. And it's also increasing over here. If we're going to the right, we're going uphill. Okay, so we can say that it's increasing on those intervals. Okay, so it is increasing between negative infinity, so all the way to the left, all the way until we get to the maximum, which is negative 0.816. Negative 0.816. Okay, so but then it's also increasing from the minimum to infinity. So it is increasing at or from 0.816 to infinity. And notice that I never used any closed brackets, and that's because at those endpoints, the function is neither increasing nor decreasing. Okay, so now let's look at where this function is decreasing, and it's just decreasing in between that those two intervals where our little ant would be going downhill as he was walking to the right. So that's just going to require one interval, and that's from negative 0.816 to positive 0.816. Okay, so that took quite some time, but really not all that difficult. All you had to do is go to your calculator, find the minimum and the maximum. Okay, number 4. Number 4 is a piecewise graphing question. And so it's a piecewise function because it's defined differently for different values of x. So when x is less than 0, we're going to use the function x plus 3. And when x is greater than or equal to 0, we're going to use, when x is greater than or equal to 3, we're going to use the function negative x minus 2. Okay, so first thing we should do, I'm going to throw a little graph on here, make it a little bit easier to see. First thing I want to do is let's figure out where is the exchange point. Where do we go from one function to the other function? And that's clearly going to happen at 3. So we're going to have a little fence at 3. And that's going to be the point where we go from one line to the other. So first let's look at the top one, x plus 3. But x plus 3, the function x plus 3 is only good when x is less than 3. Okay, so let's go ahead and graph this line, x plus 3. We know that the y-intercept is 3. Okay, and we know that the slope is 1 because the number in front of x is 1. So we're going to go up 1 and over 1, up 1 and over 1, up 1 and over 1. And because this inequality is strictly less than, we know it has to be an open circle at 3. Whereas down here, it's going to be a closed circle when we also have an equal sign. Okay, so this line that we drew is only good when x is less than 3. Okay, now this other line, negative x minus 2, is only good when x is greater than or equal to 3. Okay, so we know the y-intercept there is negative 2. Okay, and we know that the slope is -1. So we're going to go down 1 over 1, down 1 over 1, down 1 over 1, until we get to
Richard
3.
Northcutt,
Down 1
please
over
meet
1,
your ride
down 1
outside.
over 1, down 1
Richard
over 1.
Northcutt, meet your ride outside.
Okay, so there is the other half of that line that happens after x is through. Okay, now notice I used a closed circle there, and I used an open circle up here because of the inequalities. Okay, so these are actually pretty easy to do. You know how to graph lines. Basically, all you have to do is erase part of your graph. And in fact, this red part here is not actually part of the answer. That just helps us kind of separate the two pieces. Okay, so that is a piecewise function. Okay, last problem, number 5. We are going to graph these two things. We're going to graph 2 to the x minus 1 power, and then we're also going to graph x minus 1 squared minus 3. Okay, so let me throw some graphs up here. Now the point of these problems is to look at the transformations that are happening. We want to be able to look at a function and determine what is happening to the parent function. So in this situation, 2 to the x minus 1, the parent function is just 2 to the x. Now because of the x minus 1, what's happening is we're taking that basic function and we're shifting it to the left, to the right 1 unit. Remember, it's a bad dog because it's in there next to x. So we're actually moving this thing to the right 1 unit. Okay, so to graph this basic function 2 to the x, what we can do is we can just make a table of values. If we plug in -1, so 2 to the -1 power, that would be 1/2. If we plug in 0, 2 to the 0 power, that would be 1. If we plug in 1, 2 to the first power, that would be 2. If we plug in 2, 2 to the second power, that would be 4. If we plug in 3, 2 to the third power, that would be 8. So what's happening is this function is increasing exponentially, hence the fact that it's an exponential function. Okay, so that's the parent function. So now what's happening because of this x minus 1 is we're taking this function and we're shifting it to the right 1 unit. So we're taking all of these points and moving them to the right 1 unit. It looks pretty similar in this situation, just slightly shifted to the right 1 unit. Okay, so a typical EOC question there might be what kind of transformation is happening to the parent function, and we would just say horizontal shift to the right 1 unit. Okay, so the next function over here, the parent function is x squared. So we have a couple of transformations going on. One, we're moving to the right 1 unit, a horizontal shift to the right, and then we're also have a vertical shift down 3 units. So before we graph the result, let's think about the parent function. The parent function is just x squared. And x squared, we know, is just a parabola. It looks something like this. Okay, so then let's use that graph to graph the final result by doing transformations. Okay, so we're going to shift everything to the right 1 unit, and then we're going to shift everything down 3 units. Okay, so let's pick this first point, 0, 0. Okay, so 0, 0, we're going to move it to the right 1 unit and down 3 units. 1, 1, we're going to move to the right 1 unit and down 3 units. So on and so forth. 2, 4, right 1, down 3. 3, 9, right 1, down 3. And then we're going to repeat that process for the other points. And now all we have to do is connect those dots, and we have ourselves a graph. So a typical EOC question, what kind of transformation is going on here? We have a horizontal shift to the right 1 unit, and we have a vertical shift down 3 units. Okay? And if you can recognize those transformations, you will be just fine. The remaining problems to come after this video.